This video is the second video in the statistics set of videos. In particular, in this video, we're going to be looking at measures of central tendency. Now, central tendency refers to a central value for a set of data, and there's three main measures. They are the mean, the median, and the mode. And what each of those things do is they provide a different perspective on a kind of a list or a set of data's central point. We're going to take each one. I'm going to go through a few examples, explain what they are, look at when you should use them, why it's a good, central tendency to use, look at the advantages and disadvantages of it as well. To begin, I'm going to look at the mean. Now, the mean is the average of a set of numerical values. You all know hopefully how to calculate the average from even primary school, and it's calculated by summing all the values up and then dividing by the total number of values. And I have the formula here for you as well. So the sum of all values in the data set divided by the total number of values. The mean is used for numerical data when there are no extreme values because it gives the average of all numbers. If there is extreme set of data, so for example, if I had the list of ages of people who are taking a particular night course and most people were in their 20s and then there was a 70-year-old person doing it, that would be an extreme value because they're nowhere near the rest of the data points. It would not be a good idea to use the mean here because the mean is the average of all of the ages, and the person who's 70 would bring up the average greatly as they are a huge difference between people in their 20s and this person who's 70. I have an example of when to use the mean, and you can see here calculating the average test score of a class would be an idea of when to use the mean. The mean is best here because it uses all test scores to provide an overall average, giving a complete picture of the class performance. An advantage of the mean is that it uses all data points, so it gives a complete and accurate average of the data set. However, a disadvantage is basically the same thing. The mean can be skewed by extreme values, meaning it might accurately represent the central tendency if there are outliers. So, as the example I was giving of the people doing the night course, if everyone is in their 20s except for one person who is 70, is skewing the mean and making it much larger, meaning it doesn't accurately represent the central tendency of the data points. To look at a few examples, example 2.1 says, the scores of a group of students in their final math exam are shown below. Calculate the mean score of the students. To answer this particular question, what we'll do is we recall the formula for calculating the mean. The mean is just the sum of all values divided by the total number of values. Filling that formula in, we get that the mean is equal to 76 plus 82 plus 91 plus 85 plus 77 plus 88 plus 94 plus 79 plus 84 plus 82 plus 90 plus 81 plus 87 plus 92 plus 78 plus 85 and plus 89, and then all of that is going to be over the total number of values. To get the total number of values, we just add them. So we've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So divided by 17. Finishing the question out here on the side, we'll get the mean is equal to adding all of those numbers up on your calculator. We get 1,440 divided by 17, meaning that the mean will be equal to 1,440 divided by 17, which gives us an answer of 84.705, 88, and then the number continues. Now, with that particular question, it doesn't say whether we need to round it to 1, 2, or 3 decimal places. However, as it is the score in an exam, I'm going to leave it as a whole number. So I'm going to go the mean is equal to 85. However, it's completely up to you, as they don't tell you what to round it up to. You can leave it as 84.705 or 84.7 or 84.706, whatever you think is best. In example 2.2, it says a group of friends is tracking the number of steps they walk each day. The mean number of steps walked over 7 days is 10,000. Below are the number of steps walked for 6 of the days. It then says calculate X, the number of steps walked on day 7. Again, the formula here is the same. The mean is equal to the sum of all values divided by the total number of values. The mean here is 10,000. We got that from the question, as it says the mean number of steps walked over 7 days is 10,000. The sum of all values is what we get from the table. So we have 9,800 plus 10,200 plus 9,700 plus 10,100 plus 9,600 plus 10,300 plus X. All of that is then over the total number of values, and here it's over a 7-day period, so the total number of values is 7 that we have. On the next line, I'm going to add all of the numbers that we have together on the top line of the fraction. When I do that, I get 59,700, and I'm going to plus the X then at the end, and that is then divided by 7. What we're looking for here then is we're looking for the value of X. That means we need to multiply by 7 and take away 59,700 to get the X by itself. So I'll begin by multiplying both sides by 7. Multiplying both sides by 7, I'll get 70,000 is equal to 7 times 59,700 plus X divided by 7. So the multiply by 7 and the divide by 7 will effectively cancel out, as we'll just be multiplying by 1, as 7 goes into 7 once. And we'll have 59,700 plus X. Then to get the X by itself, I'm going to take 59,700 from both sides, meaning that at the end we'll be left with X equal to 10,300. Now, if we look back at what the question was asking us to do again, so it said calculate X, the number of steps walked on day 7. What we did was we worked backwards using the formula for calculating the mean, and we were able to figure out using algebra that the number of steps walked on day 7 was 10,300. The second type of central tendency is the median. The median is the middle value in a set of data when the values are arranged in ascending or descending order. So basically where the numbers are getting bigger or the numbers are getting smaller. Now, if the number of values is odd, the median is the middle number when they're all placed in ascending or descending order. And if the values are even, the median is the average of the middle two numbers. Just remember that the numbers must always be in ascending or descending order. Just remember that the numbers or values must be in ascending or descending order. Now, the median is used for numerical data when there are extreme values because it shows the middle value and it's not affected by outliers. So if we go back to the example I was talking about earlier, which was talking about the ages of people who were at a particular nighttime course, and there was all people in their 20s at it, but there was one person who was 70. Well, if we got the median, the person who was 70 wouldn't affect the median value or the central tendency as much. An example of when to use the median would be when determining the household income in a particular area. There could be some people in an area who are earning a huge amount of money each day, month, or year, which would skew the overall average amount of income. Therefore, it's important to take the median so that you get the middle value, as there could also be people who are earning very little. This would mean that you get a better sense of the typical household income. An advantage of the median is it's not affected by extreme values, or outliers as they're called sometimes, and that means that it gives a better central value when there are outliers in the data set. But the disadvantage is that the median does not use all of the data points, so it might not fully represent the data set for detailed analysis. So when you're looking at the advantages and disadvantage, they're kind of the same thing. So the advantage is that it doesn't use all values, so it's not affected by outliers. But a disadvantage is that it doesn't use all data points. The median you should find hopefully easy to calculate. Example 2.3 here says the ages of a group of participants in a workshop are shown below. Calculate the median age of the participants. What I'm going to do first of all is I'm going to list these ages in order. As you can hopefully see, I have now listed the elements in ascending order. So they're starting here on the left-hand side with the lowest, moving up to the highest here on the right-hand side. To get the median then, I start by crossing out the first and the last age, the second and the second last, third and third last, fourth and fourth last, fifth and fifth last, sixth and sixth last, seventh and seventh last. And then I'm left with a value in the center, which is 35. So then all you have to say here is the median, or the middle value, is 35. And that's example 2.3. Example 2.4 says the scores of a group of students in a science quiz are shown below. Calculate the median score of the students. Again, what I need to do is I need to list the scores in ascending or descending order. As I hope you can see now, I have listed the numbers in ascending order, meaning that at the start I have the smallest and at the end I have the largest. Exactly like the last set of data, I'm going to remove the first and the last, the second and the second last, the third and the third last, the fourth last, the fifth last, the sixth last, the seventh last. Now, as you can see here, we've been left with two values in the center this time. When you're calculating the median and you're left with two values in the center, you add the two values together, so 73 plus 74, and you divide them by 2. So you're getting the average of the two middle values, which is 73 and 74, which will give you an answer of 73.5. So when we're looking at the scores of the group of students, the median score is 73.5. The final measure of central tendency that we'll be looking at is the mode. Now, the mode is the value or set of values that appear most frequently in the data set. The mode is used for categorical data to find the most common value or category. It's usually not used as often when we're dealing with numerical data. It's more when we're doing examples like common shoe size, as I have here, or if you're looking at common car color, or even, for example, common iPhone accessory. The reason why the mode is best when we're talking about things like shoe size is because it identifies the shoe size that is most frequently bought, which is helpful for inventory management, seeing what needs to be bought, how to, I suppose, increase sales. The advantage of the mode is it's always incredibly easy to find, but a disadvantage of the mode is that it sometimes doesn't exist. So for example, if no value repeats, or for example, if there's two common colours of cars that are equally as popular in a car garage. Or you could be looking at types of candles and you might find that there's no such one because there's an even amount of sales for each type of candle. That makes analysis much more complicated, and it means that you can't always find the mode of it. However, sometimes the mode can be found, and if we look here in example 2.5, it said the number of books read by a group of students in a month are shown below. Calculate the mode of the number of books read. Here, what we're going to do is we're going to figure out how much books were read by particular types of people. So to begin with, we have here books, and we had 1, 2, 3, 4, 5, and 6. Now, first of all, we have one person for 3 books, one person for 5, one person for 2, one person for 3, one person for 4, one person for 3, one person for 5, one person for 2, one person for 3, one person for 4, one person for 3, one person for 5, one person for 1, one person for 2, one person for 3, one person for 4, another person for 3, one person for 6, and one person for 2. Here we're looking for the mode then. The mode is what is most common. So in this particular instance, because we're talking about the number of books read by a group of students in a month, the mode is 3, as 7 people read 3 books in a month, whereas one person read 1 book, 4 people read 2, 3 people read 4, 3 people read 5, and 1 person read 6. So that's how we get the mode, and it's the same for every single type of question. The questions for mode will actually usually be a little bit easier because you'll be given things like graphs or bar charts, and you'll be able to identify really easily which one is most common. That brings to an end this video on the types of central tendency. Just to remind you, we have the mean, the median, and the mode. They're the 3 types. You need to be able to calculate them. You need to be able to decide which one you should use. Remember, the mode is used when you're dealing with categorical data. So for things like car colour, for things like type of picture, for types of TV, types of sofas, types of cars, even phone case colours, types of phones, all of that would be the mode. The median is numerical data, and so is the mean. You use the mean when you don't have any major outliers or extreme values. You use the median when you do have outliers or extreme values. You should be able to answer any question now on calculating the mean, the median, and the mode. However, if you get stuck on a question or you're a bit confused, you just got to get in touch, let me know, and I can make a video on that particular question.